Right, so this is a bit of nuts and bolts that we left out in other stuff and a bit of introduction into what we are going to be learning. I shouldn't say introduction, it's a bit of extra work if you're confused about what we are learning, which you will be learning in math. This is just physics and math are very tightly, let's say, intertwined, and it's very difficult to do physics if you do not have a understanding of some mathematical operations. So we will talk a little bit about that. But first thing I want to say is addressing Herschel's experiment. So when we compare blue light and red light, we know that blue light has a higher energy because it is closer to gamma rays than red light, which has a lower energy. So now you would expect blue light to have a higher temperature because it has a higher energy than red light. And additionally, we know from grade 9 astronomy that blue stars are hotter than red stars and blue flames are hotter than red flames, and all of that is true. Blue does have a higher energy, and when I say blue, I usually mean blue-white, right? So it's not just pure blue in color. It's because as you increase in energy, it increases all different kinds of wavelengths production. So it's producing more blue wavelength, but it's also producing more red wavelength, so it just glows white because it's producing all the colors. But we saw that in Herschel's experiment, red actually had a higher temperature than blue, which is kind of contrary to what we would have thought. It's counterintuitive, and therefore we will talk about two main reasons that this was observed. So the first thing is what is called the scattering. So scattering is basically the dispersion. That's another word that you might find confusing. Is basically how much different particles can bounce off different colors of light. So blue light, because of its higher energy, has a lower wavelength, and this basically scatters easily because particles, when it hits particles, it basically bounces off of them. This is the blue light, so it has a high scattering, which is one of the reasons why the sky is blue. So like air particles, as soon as white light enters the atmosphere, all the particles in the atmosphere are bouncing, or the blue parts of that white light are bouncing off all those particles, and they're going and hitting these other particles, they're bouncing off those particles, and then they're basically spreading out throughout the entire sky. The atmosphere is technically, the sky doesn't have any color other than because of this scattering. Red light, on the other hand, has a lower energy, so a longer wavelength. So longer wavelengths do not scatter particles. They're not scattered as much. They have low scattering. And what this means is they are not spread apart by different particles. They don't bounce off of them. They just go straight through. And this is some of the reasons that we do use like red lights as stop signs, because we want a low scattering. So if it's very foggy and misty and we can't see, we want a light color that we could see from afar. So red light, because of its low scattering, is not too much affected by that mist particles or fog particles, and we can still see the red light. But if we had a blue light, they would bounce off, and then the mist would kind of become blue, but we couldn't see that exact stop sign or the exact red light. So this is very important. Because of this, Herschel used sunlight in his experiment, and we can see that if we do use sunlight, the blue light is very scattered, so the amount of blue light reaching the experiment is not the same as the amount of red light that reaches the experiment. And this is important because the red light is more intense, and so it appears to be hotter, even though one individual particle of red light, or one wave of red light, if you will, has lesser energy than one wave of blue light. There's just more waves of red light coming in because it's less scattered. The second reason is basically how our molecules interact with different EM waves. Now this is to a greater extent if we look at the UV versus the IR, but UV has a higher energy than infrared rays, but infrared rays are what we feel as heat. UV rays are not felt as heat. They cause like DNA breaks and stuff like that. And that's important, right? Because UV does have a higher energy, but our molecules, when UV hits our molecules just break. So this causes like breaks in DNA, and that's why UV can cause skin cancer, because it's causing breaking of DNA in our cells, in our skin. And therefore, our molecules react differently to UV than they do to IR. In IR, so the molecules don't absorb the UV, the UV passes through them and then they break. Similar with X-rays, right? We don't absorb X-rays. When we take an X-ray of our foot, our foot doesn't get super hot or something, because the X-ray waves are passing through the molecules in our hand or chest or wherever we're taking an X-ray of, our foot or whatever. IR, on the other hand, and microwaves, kind of. So IR, the molecules in our skin absorb the IR radiation, and so the molecules get heated up because they're actually absorbing the radiation or the waves that are hitting them if they're in the infrared spectrum of those rays. They do not absorb these guys. They do absorb this, and this is why we feel this as heat, because the molecules are absorbing this radiation. And that is similar to how microwaves are going to heat up food. Microwaves specifically target water molecules. So water molecules absorb radiation very, very well in the microwave range. So when we put a bowl of food in the microwave, the water in our food is absorbing the microwaves and is getting heated up. And that's why our food gets heated up. And that's why if we're exposed to microwave radiations, we basically get cooked. It's not, that's as unpleasant as it sounds. You do not want to be exposed to microwave radiations of any shape or form. So microwave is a dangerous device. Potentially, if you could fit inside one, it would kill you. Okay. Next to our math bit. So I want to talk a bit about what a function is. So you can think about function as a box, all right, which performs some operation on some numbers. So let's say I put 1 in here. That's my input. So I have a list of input values and I have a list of output values. So let's say I put 1 in, it's going to go through my function and I'm going to output 1. If I input 2 in, it's going to go through my function. I'm going to output 4. 3 is going to output 9. 4 is going to output 16. And you could probably guess what this function, I'm doing air quotes here, what this function is. It is the function of x squared. Because whatever input I take, I multiply it by itself, which is the square, and then I give you that output number, right? So 2 squared is 4. 3 squared is 9. And you can have many different kinds of functions, in grade 9 you did linear systems, 2x minus 1 is a function, which is another box which is labeled 2x minus 1. So if I put 1 inside, it's going to become 1. If I put 2, that's going to be 3. If I put 3, it's going to be 5, right? And this is the operation basically that I'm doing to the input numbers, and I'm giving you an output number. So the important thing about a function is that there is no way that I have a... So the important thing about a function is that for any given input number, so each distinct input, so 1, 2, 3, 4, 5, 6, I can put any number I want into here, gives me only one output. So for example, like if I, come in on a Monday and I take this box of 2x minus 1, that's my function, I put 1 inside of it, every day, no matter when I do it, I will always get the same answer of 1. But you consider the function of, what is not a function? Consider, I don't know if you've seen the square root. Hopefully you know what a square root is. And let's take the square root function of 25. So again, hopefully you might not have seen this at this point, but we will note, I think you have, you did this in grade 9. Let's say I start this function up and one day square root of 25 gives me a 5. But on another day, square root of 25 could also give me a negative 5, right? Because 5 times 5 is 25, so square root of 25 could be 5. Therefore, square root of 25 is 5. But negative 5 times negative 5 also gives me 25. So square root of 25 could also be a negative 5. And this is not a function because one input value could give me two output values, right? So if I come in on one day, 25, I put it in this box, it could give me 5. But another day, it could give me negative 5, right? Depending on how the box is feeling or whatever. Obviously, hopefully you understand that that's hypothetical. But the problem is for one input value, I'm getting more than one, there's more than one possible output value. So this is not a function. Functions are defined by their one-to-one correlation. So for every input value, you must have exactly one output value. It could go like the other way. There could be functions where like whatever number you put in, you get the same output for some reason. And that's fine. It's okay if you put in a bunch of input values and they all give you the same answer, but one input value cannot give you two different answers like here. This is one input value giving you two different answers, and that's not allowed in a function. All right, so that's what a function is. So you'll learn that in grade 11 math. My eraser's not working. Let's see. Okay, this is getting annoying. I'm just going to discard, go back, and open this again. There we go. Sorry about that. So we talked about how a function was a box, essentially, that did a given operation on an input number. So if you put, we talked about the function x squared, functions 2x minus 1, all of those are functions because they took input values, which are x values essentially, and they outputted y values, which are our output values. So they did a mathematical operation on values to give you an output. So the function that we're going to talk about is something called a sine function. So sine functions have everything to do with right angle triangles. So if we take a right angle triangle, like so, and we said that this angle was 30. All right, what you will notice that you can try this at home. Hopefully you will learn about trig in grade 10 math, so your math teacher should be doing this with you at some point or explaining some version of these events. But if you take this angle, we know that this angle would automatically be 60 degrees due to all angles in the triangle being added up to 180 degrees. But we're going to focus on the 30 here. So in this triangle, whenever I take the ratio, hopefully we're also familiar with Pythagoras theorem, which says that a squared plus b squared equals c squared, where c is the hypotenuse, right? So hopefully that's all right with you. We know what that is. Okay, just in case we do not know what that is, in a right angled triangle, you always have a hypotenuse, which is c, which is the longest side in your right angle triangle. It's opposite to the right angle. Like, that's the hypotenuse. And the other two sides are just like regular old sides. Just call them A and B. It does not matter where you put the A. I could have called this A or this B. It does not matter in the slightest. what I know that in a right angle triangle is that a squared plus b squared equals c squared. And so if I want to calculate, this is if I want to calculate c, the hypotenuse. If I wanted to calculate a or b, I would do c squared minus b squared equals a squared, or c squared minus a squared equals b squared. Again, those are the same thing because it does not matter which one's a or which one's b. So that's the Pythagorean theorem. But essentially what we will notice in a right angle triangle with an angle of 30 degrees, as this angle, is basically that the three sides will be in this kind of order, roughly. So these are three sides of the triangle. And note that these two sides, so the opposite side to this angle, so 30, the opposite side is 1. So opposite means like there's the side that's, opposite of that angle. I don't really, hopefully you can see why this is the opposite side. I'm just like drawing a line saying the opposite, same way, opposite to the angle. And the hypotenuse, you'll notice that they have the same ratio. So if I do 1 divided by 2, it's the same as 3 divided by 6. If I want to draw another triangle, same right angle triangle, angle of 30, and if this is 5, this will be 10. And therefore this will be square root of 75, which is like around 7 point, no, square root of 75 is 8.7-ish, I'm guessing, not sure. But these two, the opposite divided by the hypotenuse, will always be a constant ratio. It'll be 1/2, right? In this case, because the angle is 30. And this is a fact for right angle triangles, and this is basically what trigonometry is based on, or sine functions are based on. So essentially we see here that the opposite side divided by the hypotenuse is always the same value. It's equal to 1/2. So we can think of the new box here that we're going to draw, which is what we're going to call sine x. The technical term for this is sine, which means a curve, which relates to how the graph of a sine function looks like, but we're going to use just sin, which is the short form for sine x. The x values, this is just like any other function, like x squared or 2x minus 1, or is just a function that takes a input value, so it takes in angles. So input for a sine function are angles. So it takes in, angle 30, and then the output is the ratio of the opposite to the hypotenuse sides of a triangle with an angle of 30. So if it takes in 45, this is going to do 0.707. That's going to be the output. If it takes in 60, it's going to be, well, I don't know what, 0.85, I think, somewhere around there. But if it takes in 90, it's going to output 1. If it takes in 0, it's going to give you an output of 0. Again, these are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, right? So those are the inputs are always angles for a sine function, and the output is a ratio of sides. So it's giving you the opposite side divided by hypotenuse is 0. The opposite divided by hypotenuse is 1/2. Opposite divided by hypotenuse is 0.707. Opposite divided by hypotenuse is 0.85. If in this triangle, that's a horrible triangle, this angle was 60 degrees. So opposite divided by hypotenuse would have given me 0.85 for this triangle. No matter what, they can be any side lengths, but the ratio has to stay the same. So that's what the function sine x is doing. It has enormous applications, as we will see. And on your calculator, all you have to do is press sine and then the angle that you want, and it will give you an output corresponding to whatever that value. What it's doing is it's taking the ratio of the opposite to the hypotenuse side in a triangle with an angle that you have indicated. But you don't have to know any of that. Obviously, you just press sine of something into your calculator and it gives you the answer to that value. Note that we can only take sine of angles. That's also very important. I'll be talking about it again, but sine, what comes after a sine always has to be an angle. And this is very important for what you will, hopefully your thought process. So you can't put sine of like 2 centimeters or 5 meters. That doesn't exist. It has to be sine of an angle, and only then the function is valid. Okay, so sorry that took long. Probably not going to talk about a lot of this in class. So if you do want to learn about sine functions a little bit ahead of time, you can always ask me questions. Just post them on the comments or ask me in class. All right, see ya.